Good morning, Aerostealth here. It is Monday, December 26, 2023, and I just wanted to shoot a quick video on the urban heat island enhancement technology we've developed. This is kind of a pun, but we'll get into that later. First, I wanted to cover a charging cycle I did yesterday on my car. Rather than just charge off peak at a cheap rate, which is 4.7 cents a kilowatt hour, I decided, since it's winter and the house itself isn't using that much of my solar production, I wanted to do an experiment to see how much charging I could get done in the daytime using just solar power. Now, to do that, my EVSE runs at 7.2 kilowatts, and my system is only a 5.1 kilowatt system and only produces about 4 kilowatts peak power during the especially on a winter day. And I only got about 5 hours of charging that I can do and still be using all solar power. So I did that. I started at 9:30 in the morning and I finished at 2:30 in the afternoon. But what I had to do was get the EVSE out of the car and operate it on 240 volts. And when I do that, it's only putting 2.88 kilowatts into the car, which is well underneath my solar production. And the house is maybe drawing another kilowatt at that time. I made sure, that I had all the lights shut off that I didn't need. It was a nice sunny day. And so when I got done, basically I'd pumped 14.4 kilowatts into the car to charge it. And then that night after midnight, I started charging at 7.2 kilowatts at a reduced at that reduced rate, 4.7 cents a kilowatt hour. And I got the car fully charged to 90% by morning. And I think the total amount of energy the car needed to charge to 90% was 38.04 kilowatt hours. So I got it done. It was a nice experiment, and technically I probably lowered my cost to per gallon equivalent to charge the car from $1.74 a gallon down to $1.08. However, it's not something I want to do on a regular basis because I have to unplug and plug in the EVSEs, and it's not good on those big 240 volt sockets to constantly be plugging and unplugging devices in them. So it's not that you can't, it's just that you shouldn't do it on a regular basis. It wears them out, and it's hard on them. So anyway, it was a nice experiment. So anyway, so you may be wondering about my new invention here, UHEAT. It just came about as a joke. I was talking to my friend Phil Knox on the phone, telling him about how I had been watching a video on locomotives and how they're constructed. It was an engineering video where they had transparent diagrams of a locomotive, and they could go rotate around it, showing all the parts, and they went through all the parts of a locomotive. It was a very interesting video. And of course, I've been familiar with their what they call dynamic braking on locomotives for a long time. Essentially, it's regen braking, like you have in an electric car. But a diesel locomotive, which is really a hybrid. It's the diesel engine's driving a generator, and that generator drives electric motors, and those are the traction motors for a diesel. And so they can do what they call dynamic braking, where they're generating electricity from these electric motors, but they don't have anywhere to put it because there is no battery. It's not like even a Prius or an electric car. There's just not a large enough battery to put that power into, so they literally dump it into the atmosphere. And the way they do this is in the roof. They have resistance electric heaters with fans underneath them, and when they're doing dynamic braking, these heaters heat up, and there's louvers that open on the top of the roof, and these fans are blowing this hot air up out of the roof. And so I was joking with my friend Phil Knox about, this could be a nice new invention for electric cars. Let's get rid of this regen braking, and start just put a small electric heater in the roof of the car and dump all the heat energy into the atmosphere. And we could call this urban heat island enhancement technology. Now technically, the urban heat island effect is caused by all the buildings and pavement in a city hold more heat during the day and then release it at night. So the average temperature in the city, like in Las Cruces, the average temperature there is 3 or 4 degrees higher than it is where I live out in the country. And that's due to the urban heat island effect. And I wrote a blog on this 3 or 4 years ago about how all the internal combustion engine vehicles, how much heat they were dumping into the air, because only about 30% of the energy from gasoline, or no more than 40% on a diesel, goes into running the vehicle. The rest is dumped as heat. And I just made some rough back of the envelope calculations that all the heat from all the vehicles in Las Cruces in a day would be enough to boil all the water in an Olympic-sized swimming pool. And so I wrote this up and sent it to the city sustainability officer. And at that time I was collecting blogs, so that's kind of where the joke comes from. Of course, all these ICE vehicles are also doing regular braking, and they're dumping all the heat from braking all these vehicles into the atmosphere also. So I didn't want them to have this advantage that electric vehicles don't have. Wasting all this energy from braking and just dumping it as heat into the air. And since electric vehicles don't do this, if you're using regen braking, we had another way to allow them to do it. And that is use a regen to run heaters and then dump it as heat. So that was the joke. And I posted it online, and someone come back and he says, we changed the acronym to UHEAT. In other words, urban heat, and he dropped the island part, and enhancement technology. So urban heat enhancement technology is what he calls it, UHEAT. So look for it on the next electric car you buy. Take care, everybody. We'll see you around the corner. Bye-bye.